Hello everyone, I am Mr. Ashok Kumar from VTU projects.com and AKLC. So in this particular video I am going to explain you about the project attribute based data sharing scheme revisited in cloud computing. So all I am going to do in this particular video is explaining you what actually this project does. I am not going to bother about how we are implementing this, okay, because you are just started to learn this project, you are not a master of it, so you will be requiring a lot of time to understand the implementation part of the project, okay. So I request you people to go to your college coordinator and explain the project like the same way I am going to explain you in this particular video, okay. So definitely they are going to ask you one or more questions like, you know, tell me more about the algorithm or tell me more about the technologies, etc, etc. So whatever questions they are going to ask you, so just promptly reply them saying that you just started to understand this project, you are not a master of it, so you will be requiring 1 or 2 days of time to answer those questions, okay. And all those questions your colleges are asking you, you people should be immediately redirecting it to me on this phone number, or you can type all those questions and, you know, mail it across to me on this email address. So I am going to answer to those questions immediately, and then you people can go back to your colleges and answer to them, okay. So these are the things that I am going to explain you in this particular video. So firstly I will be taking you people to quick facts, where I will be answering some of the commonly asked questions about your final year projects, followed by problem statement. Here I am going to state the problem clearly, like what particular problem we are solving in this project. So that problem statement I am going to formally define it. So and then I am going to explain you some of the existing systems available to solve the problem that we stated earlier, along with their drawbacks, and then I am going to, you know, mention what system we are actually going to propose in this project along with its advantages, and at last I am going to mention the hardware and software requirements of this project. So coming to the quick facts about this project, so here you people have to be ready with the answers for these many questions, because these questions can be asked at any point of time by your college internals or externals or whoever concerned about your project, okay. So keep the answers for these questions you know, ready, okay. So firstly the base reference, like where did we get the idea from, like what is the base paper for this particular project, okay. So remember, for this particular project has been taken from IEEE 2016 paper. So it's most importantly it's a transactional paper. So the recent IEEE 2016 paper we are going to use as a base reference to our project, okay. So and then, you know, the domain of this particular project comes under cloud computing, and then the algorithm we are going to use in our project. So I am going to name the algorithm that we are going to use, but you cannot understand the working of that algorithm right now. So you just have to mention the name of the algorithm we are going to implement in our project, okay. So the algorithm name that we are going to implement in our project is called as, so CP-ABE. Okay, so I'll be in short mentioning it as CP-ABE. Okay, to be more specific, I will just call it as CP-WABE-RE. Okay, so this is the algorithm that we are going to implement. So expansion for this will be ciphertext policy attribute based encryption scheme with removing escrow. Okay, so this happens to be the name of the algorithm that we are going to implement in this particular project. Okay, so the detailed working of this algorithm you are going to understand only in the project classes. So as of now you just have to mention the name of this particular algorithm. Okay, and then coming to the platform basically indicates where actually our project will be executed, like the demo of our project will be shown where, in which of the machines, like that, okay. So just remember that we are going to show the demo of our project in a live cloud environment, okay. And you people should be highlighting this point, because we are the only people to do this. So most of the other institutes and any other cloud computing projects and all will be deployed in the local laptops, and they will ask the external to assume those laptop itself as cloud machines. Okay, that doesn't give a a real world feel. But what we are going to do, so we are going to deploy, install our project in a live cloud environment, and we are going to execute the project from live cloud. So anyone sitting in any geographic area can access our project readily. Okay, so that's the advantage and the core feature of this project, which you need to highlight it for sure. Okay, so just say that we are going to purchase the cloud from Amazon Web Services, or there are many other cloud service providers. Okay, so we are going to purchase some cloud space from one of those service providers, and we are going to deploy our project in a live cloud. Okay, so live cloud environment will be the platform that we are going to use in our project. Okay, so in the lines of code, the number of lines of code that we are going to write in our project will be around 4,000 lines of code. Okay, so you can compare this number of lines of code with any other institute project or any other senior projects. So I can say that we are going to develop almost 4 times bigger project than those people do. Okay, so you can compare it. Most of the projects will be completed within 1000 lines of code, or sometimes 800-900 lines of code, like that. But our project alone will be taking around 4,000 lines of code. That doesn't mean that the project will be complicated or it will be difficult to understand. So each and every line of code that you are going to write will be given a proper justification for it, so it will be easier to understand as well. Okay, and the last thing that you need to know is the percentage of the database used. So we are going to use around 8 to 10% of the database. So the reason why I'm going to mention this point here is because VTU allows us to use maximum of 20% of the database. You are not supposed to use beyond that. Okay, so but we are going to prove that we have used only around 8 to 10% of the database, so we can development of the project. Okay, so we are in a safer side because VTU allows us up to 20% of the database, but we are using only around 8 to 10% of the database. So coming to the problem statement, here I am going to explain you what problem we are trying to solve in this particular project. Okay, so before I state the problem, I want you people to be aware of some prerequisites in this particular projects. Okay, so before getting into the project details, I want you people to be aware of the common terms like encryption, decryption, and what you mean by plain text, and what you mean by ciphertext, and what you mean by cryptographic system, like this. Okay, so these are the things that you people should be knowing very well before getting into the project details. Okay, so I believe you people would have learned this in your 7th semester computer network subject. Okay, so let me explain you in brief about these things now. You know the meaning of plain text, right? Okay, any textual data in raw format, okay, without performing any operation on it, we call it as plain text. Say for example, hello. Okay, so to convert this raw plain text into unreadable format to secure this particular data from a third party. Okay, so we are going to perform some mathematical operations or some things. We are going to jumble or do some circus, and we will come up with some unreadable format. Okay, so say for example like this. Okay, so this hello is called as a plain text. Okay, it's the original text. Okay, so whereas these things I can call it as a ciphertext, unreadable format. Okay, so it need not be special characters. It could be some numbers, or it could be some letters again, like this. Okay, so this hello is called as a plain text, and this thing we call it as a ciphertext, right? So now coming to the encryption, the first part. Encryption is the process of converting a plain text into ciphertext, that you people guys know, and the reverse process of it we call it as decryption. Okay, decryption is the process of converting the ciphertext back into the plain text. Okay, so and now about cryptographic system. Okay, the meaning of cryptographic system. What do you mean by cryptographic system? So cryptographic system is that which provides 3 basic operations. Okay, like it should provide the operation to generate the keys. okay, like private keys and public keys, like that, and it should provide the operation to perform encryption, and it should provide the operation to perform decryption. Okay, so cryptographic system is the one which provides three operations: generating the key pairs, encryption operation, and decryption operation. Okay, so there are many cryptographic systems available. So one such cryptographic system is CP-ABE. Okay, so CP-ABE is one such cryptographic system using which we can generate the key pairs, and then we can perform the encryption operation, and then we can perform the decryption operation. Okay, so the expansion for CP-ABE is ciphertext policy attribute based encryption. Okay, so this is the expansion for CP-ABE. Okay, so I'm going to repeat this. CP-ABE is one of the cryptographic system using which we can generate the keys, we can perform encryption operation, and then we can perform decryption operation. Okay, this is the system that is already available and anybody can use it. Okay, but in this particular cryptographic system, okay, so it is having one major drawback. Okay, so this particular cryptographic system is prone to one of the security attack called key escrow problem. Okay, so this is actually our problem statement. Okay, the existing CP-ABE cryptographic system is prone to the security attack by name key escrow problem. Okay, so we need to solve this particular problem. That is where our project lies in. Okay, I'm going to repeat it again. So the problem statement of this particular project happens to be CP-ABE is limited to a potential security risk that is known as key escrow problem. Okay, so we need to modify this cryptographic system so that it overcomes this particular problem. Okay, so that is what our project aims at. Okay, so this particular diagram that I have pasted right now will be explaining you what actually key escrow problem is all about. Okay, so if you carefully observe this particular diagram, so there is an email message. So there is an email message, okay, and along with the key to decrypt that email message. You can see this is the encrypted email message, and this is the key required to decrypt that message. Okay, so both the encrypted message and the key required to decrypt that message is being sent to the user, is been sent to the valid user. Okay, but who is going to provide this email message along with the key to the user? It is an ISP, internet service provider. Okay, so he is the third party, right? He is the one who is going to provide the key, and he is the one who is going to provide the encrypted message. Okay, he is a third party, but he is a trusted one. Internet service provider like BSNL, or mail service provider like Google, Yahoo, all these people are trusted one. Okay, but these people are third party to this particular user. Okay, so I can say that this user is actually dependent on this third party. Okay, this third party is called as escrow. Okay, the problem arises when some hacker compromises this third party. Okay, say for example FBI, the secret detective agency. Okay, so they will have full access to this internet service provider. They will be able to read this email by decrypting its content, right? So this is where user will be facing the problem, disadvantages. Okay, so I would summarize this key escrow problem. So if you can go to web, and you can just go ahead and start typing key escrow problem. Okay, so there you can see the Google answers. Okay, so key escrow is an arrangement in which the keys needed to decrypt the encrypted data, okay, are held in escrow. Escrow is nothing but a third party. Okay, so the keys required for decryption, it will be present with the escrow. So somebody else can compromise that escrow and get that keys, therefore getting the original data itself. Okay, so that's the problem the current CP-ABE cryptographic system will be facing. Okay, so our intention in this particular project is to overcome this problem. So coming to the existing systems and their drawbacks, here I am going to explain you some of the existing solutions available to solve the problem that we stated earlier, and also their drawbacks as well. Okay, so remember, you are not supposed to understand the working of existing systems, because IEEE author have already studied the existing system and he came to a conclusion saying that none of the existing systems can be used. Each one of them have their own drawbacks. Okay, so I'm just going to mention the existing systems available to solve the problem that we stated earlier. So if you can see here, there are 4 existing systems that the author explains in the IEEE paper. He also mentions the drawback of each one of them. Okay, so the first existing system was been introduced by Sai and Water, and they introduced fuzzy identity based encryption. Okay, so the drawback of this particular system is no security proof has been provided. Okay, it's just a theoretical solution where they just say that do that and do this, so but the proof of that security has not been provided. Okay, so this is the drawback of the first existing system. And the second existing system was a distributed KP-ABE scheme, and it was proposed by scientists by name Chase and Chow. Okay, the drawback of the second existing system is performance degradation. Okay, so it will have a serious issue on the performance in terms of communication between the clients, and also in storing the secret keys. Okay, so it will have a couple of drawbacks. One, performance degradation in terms of communication, and another performance degradation in terms of space complexity. Okay, later the same scientist Chow proposed another scheme called anonymous private key generation protocol for IBE. Okay, but the drawback of this system is that the user's identity is not known to public. So in this particular scheme, the user's identity is not at all known to public. Okay, hence it is not IBE at all. Okay, so just remember, IBE indicates identity based encryption, which is same as attribute based encryption. Both are same. Okay, one special feature of identity based encryption is that the user's identity, the public key, will be known to public. Anybody and everybody can get the user's identity. Okay, but in the paper that Chow has been proposed, here the user identity is not at all known to public, hence it cannot be IBE at all, so it cannot be considered as an approved solution. Okay, and the fourth existing system is proposed by Okay, he proposed an improved security data sharing scheme based on classic CP-ABE. Okay, so here also the drawback will be the computational cost. Okay, so here the computational cost in generating the user secret key increases. Okay, because the protocol which he proposed, it requires intensive communication between two parties. Okay, therefore computational cost will be too much. Okay, so these are the existing systems along with their drawbacks. So here I am going to mention the system that we are going to propose along with its advantages. So as mentioned earlier, the proposed system is termed as ciphertext policy weighted attribute based encryption scheme with removing escrow. Okay, so in short we are going to call it as CP-WABE-RE. Okay, so this is the technique that we are going to implement for solving the problems that we stated earlier. Okay, so as I told you earlier, you cannot understand the working of this algorithm right now, you just have to mention it. Okay, so whereas the detailed working of this particular solution you are going to learn only during the project classes. Okay, so coming to the advantages of the proposed system, I can say that it's going to solve the key escrow problem, okay, because in our project there will be no escrow at all. I mean, there will be no third party at all, okay. Without the third party, how that cryptographic system can be implemented, you are going to see during the project classes, okay. And we can say that it solves all the drawback of the existing systems that we explained earlier. I mean, whatever the drawback that we saw, like computational, cost, the storage complexity, all those problems we are going to solve in this particular project, okay. So now coming to the hardware and software requirements. So here I am going to tell you, the specifications of our project, okay. So to implement our project, we don't need any specialized hardware, because this is a software intensive project. So a machine with moderate configuration like 1.6 GHz processor and 4 GB RAM and a minimum of 40 GB hard disk, okay. So these are the minimum configuration that are sufficient enough to implement our project, okay. So now coming to the software requirements. So here I am going to explain you in detail the technologies we are going to use in our project, okay. So I can divide the technologies into the front-end technologies and the back-end technologies and other tools we are going to use, okay. So in the front end we are going to use technologies like HTML, CSS, JavaScript, Ajax, jQuery and Twitter Bootstrap framework, okay. So these are the things that will be used in the front end. Okay, so in the backend we are going to use languages, the core Java, advanced Java and J2EE. So in J2EE we are going to use JDBC, Servlet and JSP, okay. So these are the things that we will be using in the backend. So and apart from that, we will be using tools like Eclipse IDE and then Apache Tomcat server, etc. Okay, and most importantly, do not forget to mention the deployment environment, okay. So deployment environment indicates the platform, okay, where actually we are going to run our project. Our entire project will be installed in a live cloud, okay. So we are going to purchase the live cloud either from Amazon or from Red Hat. So there are a lot of cloud service providers, Google Cloud. So we are going to purchase one of the live cloud from any of the service providers, and we are going to install our project over there. So anybody across the globe can be using our project readily, okay. So this will be the deployment environment. So that's it about this particular project. So I hope you guys have understood this. Any questions or any concerns you have about this project, so please feel free to contact me on this particular phone number, or you can get in touch with me on this email, okay. Thank you so much.